All right, so welcome back to Simplifying Radicals. This is day 2 because in the previous lesson, we covered how you can rationalize the denominator when it's a monomial. And then today we're going to extend upon that, and we are going to rationalize binomial denominators. By the end of this lesson, you should be able to recognize when a radical expression is fully simplified and correctly rationalize a denominator with 2 terms. All right, so starting off, we are going to go over some steps that I like to use when rationalizing that binomial denominator. All right, so we have step 1 is to multiply the top and the bottom of the fraction by the conjugate. Okay, so this is going to be the same expression as the denominator, but with the opposite sign in front of our radical part. Then we have step 2, combine like terms in the numerator and in the denominator. Step 3 is to simplify the radical in the numerator, because you should have already canceled out the 1 in the denominator. And then step 4 is to simplify the fraction by factoring out your greatest common factor, your GCF, from the numerator and the denominator. All right, we're going to start off with our first 2 problems of just reviewing a little bit before we get into actually rationalizing the binomial denominators. All right, so we are going to completely simplify each radical expression. So when we look at number 1 here, we are going to see that we have that 7 plus the square root of 75 times we've got that negative root 3 plus 13. So I'm going to start off by just checking to see if any of the radicals can be simplified before I start multiplying. So I'm going to look and see that right here, that square root of 75 can be simplified. Okay, so I'm going to just start off with that. We have that some factors of 75 are going to be 25 and 3. And so that 25 can be factored into 5 times 5, which will give you your pairs. And so I'm going to pull that out, and I'll be left over with that 3. So I'm going to rewrite this real quick as just that 7 plus now 5 root 3 times that negative root 3 plus 13. All right, so now that we have that simplified, we're going to see here we have a binomial times a binomial. And so we are going to distribute by FOILing. Okay, so here I'm going to go ahead and take that 7 times that negative root 3. So I'm going to get negative 7 root 3. And then that 7 times that 13. Then we're going to take that 5 root 3 times negative root 3. So we're going to get a negative 5, and we'll have times 3 since it is that root 3 times root 3 to give me a whole 3. Plus, we'll have that 5 root 3 times 13. So 5 times my 13 root 3. So this is where everything's coming from. Now I'm going to go through and work through this and simplify. So the first one, we're just going to have that negative 7 root 3 plus, and then we'll here have that 7 times 13, which is just going to give me 91 minus the 3 times 5, which is 15, plus my 5 times 13, which will give me 65 root 3. All right, so we're going to look here, and we are going to combine our like terms. We're going to see here that we have our constants in the middle. So we can combine those, as well as the fact that the first term and the last term do have the radicals with the same radicand. So therefore, we can combine them by adding or subtracting the coefficients. So we'll have that negative 7 plus 65, which will give me a positive 58 root 3, plus that 91 minus 15 will give me a 76. Okay, so we're going to have a final answer here of 58 root 3 plus 76. All right, so moving into our second problem here, we're going to have that negative root 7 times negative root 44 minus the square root of 54. Okay, so kind of like how we did in the previous one, I'm going to start by just simplifying my radicals if I can. So that 7's prime, I'm going to skip over it. But here when I get to that 44, I can factor that into 4 times 11. And then that 4 will give me my 2 and 2 that I can pull out. And then we'll have that leftover 11. Then moving into my 54 here, I can factor that into 9 times 6. And then we'll have that 9 is 3 and 3. My square root of 6 is 2 times 3, which won't give me any pairs, so I'm just going to leave it as a 6. So I'm going to rewrite this. We'll have that negative root 7 times negative 2 root 11 minus our 3 root 6. All right, so we are going to go ahead and distribute this. We've got that negative root 7 times our negative 2 root 11. So we'll actually have that negative times negative to give us a positive 2. And then we'll have our 7 times 11 underneath the radical. Then I'm going to multiply. We've got that negative root 7 times our negative 3 root 6, which will give us another positive. We'll have that positive 3 root, and we'll have 7 times 6 underneath. All right, and so just checking here. I left them unsimplified, sorry, just because I want to look and see if I can factor out any more. But we've got that 7 times 11. Those are both primes. So we're going to go ahead and we can multiply those together to get 77 under that radical. And then for the other one, we do have that 6 can be broken into 2 times 3, but we still don't have another pair with that 7. So I'm going to go ahead and multiply, and we'll get that 3 root 42. All right, so here, since the radicands are different, we are not going to be able to combine them any further, and that's going to leave me as my final answer as 2 square root of 77 plus 3 square root of 42. All right, so now let's move on to number 3, which number 3 is going to be using those steps that were provided to you up above. And so we have 31 divided by that 3 minus 2 root 27. Right off the bat, I do see an unsimplified radical, so I'm going to real quickly simplify. So I'll do some scratch work down below so you can see where I'm getting that from. So I'm going to be factoring that 27 into 9 times 3. And that 9 can be broken down into 3 times 3, which will give me a pair that I can pull out to multiply by that 2 that's already out front. And we'll have that 3 left over. So this is where I'm getting negative 6 root 3 from. And I'm just going to come back up here and rewrite this. We'll have that 31 over, we've got our 3 minus 6 root 3. And so now that we have that, we're going to follow through with those steps that I provided you with earlier. We're going to multiply by our conjugate. So that we're going to keep our denominator, but just change the sign in front of the radicals. So we'll get 3 plus 6 root 3. We're going to do that to the top and to the bottom. So remember, this is us multiplying by a creative 1. We're not actually going to change anything. And so for our numerator here, we are just going to distribute that 31 to both terms. We got 3 times that 31 will give me 93. Plus, we'll have that 6 times 31 is giving me 186. And then we'll have that root 3. And then for our denominator here, I'm going to do a little bit of scratch work to show you what is happening. But when you multiply by the conjugate, the radical terms should cancel out. And we're using the difference of squares here. So that's what I'm going to show you in that step. But I'm going to just show you a little bit of scratch work of exactly how the radicals do cancel out for those of you questioning it. So we have our 3 minus 6 root 3 times our 3 plus 6 root 3. So we've got our 3 times 3, which will give you 9. Then we have our 3 times that 6 root 3, which will give me a positive 18 root 3. And then when I start at that negative 6 root 3 and I multiply it by 3, we are going to get a negative 18 root 3. And then lastly, that negative 6 root 3 times a positive 6 root 3 is going to give us a negative. And then we have 6 times 6, which is 36, times our root 3 times root 3 gives me 3. All right, so here noticing that my radicals, my two terms in the middle, they are going to cancel out because we have a positive 18 root 3 and a negative 18 root 3. So like I said, if you are multiplying by the conjugate correctly, they should cancel out. And so we're left with that 9 minus, and we'll have that 36 times 3, which will give me 108. And so when I subtract, I'm left with negative 99. Okay, so like I said, this is our difference of squares. We have our a squared minus our b squared. So to clarify, our a squared is that 3 squared. So we have 3 times 3 is where we got that 9 from. And then we've got minus, and whatever your b squared is, which is that 6 root 3 in this scenario. So like we said, that 6 root 3 squared just gave us that 108. And so in your work here, instead of you working that every single time, you would just use that difference of squares to write out. We'll have that 3 squared minus our 6 root 3 squared. And then I'm going to work through this a little bit quicker since I already have the numbers down below. But just working through to kind of simplify, we'll have our 93 plus our 186 root 3 over, and then we'll have that 9 minus our 108 that you get when you actually square the numbers. Then using the subtraction, we get that 93 plus 186 root 3 over our negative 99. Now, the reason why this is not our answer is because we haven't followed through with that last step of pulling out our GCF. We have that 93, 186, and negative 99 are all divisible by 3. And so we are going to pull out that GCF of a 3, and that's going to leave us with 31 plus 62 root 3 over negative 33 as my final answer here. All right, so now let's move into number 4. Okay, and looking at number 4 here, we are not going to follow through with the steps from above just because looking at my denominator, while there is a radical down there, we don't have the binomial. But I do see right off the bat an unsimplified radical. And so once again, that's where I'm going to start. I'm going to take that square root of 16 is just actually going to give me 4. And so I'm going to rewrite this as negative 2 root 2 minus 5 over 4. And this actually becomes my final answer here because all radicals are simplified. They're out of our denominator. And the fact that we don't have a GCF that can be pulled out of every single term. While yes, the 2 and the 4 are divisible by 2, that 5 is not, and so it won't be able to pull out of every single term, and so we leave our answer as this. All right, so that was a very easy one. Now let's move back into some slightly more challenging ones with number 5. So looking at it, number 5 here, we do have a radical in denominator. I do have a simplified radical already. So I'm going to just jump straight into my steps of multiplying by the conjugate. And so I'm going to multiply to the numerator and denominator. I'm going to multiply 7 plus the square root of 11. Okay, and so when I do that here, I'm going to distribute into the numerator. We'll have that negative 77, and then minus our 11 root 11. As for my denominator here, using our difference of squares, we are going to have 7 squared, so our a squared, minus that root 11 squared. Okay, so going through and squaring them, I'm going to keep copying over my numerator. We'll get that 7 squared is 49, minus our root 11 squared is just going to be 11. And so when I subtract the 2, we are going to be left with negative 77. Minus 11 root 11 over that 49 minus 11 will give me 38. Okay, and so with that being said here, we do not have a GCF to pull out. And so this is my final answer. And we can move into our last problem, number 6. Okay, so with number 6 here, once again, I am going to start off by simplifying. We have that radical in our numerator here that can be simplified. The square root of 9 is just 3. And so we're going to get 3 times 3 is giving me 9 over that 7 minus 4 root 3. Okay, so now that we have it simplified, let's start off by multiplying by our conjugate. We're going to multiply by that 7 plus 4 root 3. Okay, so then multiplying for our numerator, we're going to distribute. We've got that 9 times 7 gives me 63. Then we have 9 times 4 will give me 36. And we'll have that root 3. And then as for my denominator, we'll have that 7 squared minus, and then we'll have our 4 root 3 squared. Okay, so working through this, we've got 63 plus 36 root 3 over, we'll have 49 minus, and so in this one here, we'll have our 4 squared is going to give me 16 times 3, because that root 3 squared. And then when we actually multiply that together, we'll get 48. And so I'm just going to rewrite this as that 49 minus 48, which just leaves you with a 1. Now, in class, we did talk about this, so I just want to mention it. If you ever have a fraction and you're getting a 1 in our denominator, we should not be leaving that as a fraction. We should be just rewriting it like so, that 63 plus 36 root 3, no fraction needed. Please do not rewrite it as over 1, or it is not fully simplified. All right, so that is it for this lesson. Okay, we do just have a little bit down here of just going over simplified radicals basics. So we have an expression with radicals is simplified when all of the following conditions are satisfied. Okay, so some key things are going to be the radicand has no factor raised to the power greater than or equal to the index. Okay, in that sense, it just means you fully simplify the radical. The radicand has no fractions. Okay, so in that sense, you would want to break it up. Okay, so just showing you, you would rewrite it as this, where you would have a radical in the numerator, a radical in the denominator, and then you need to turn around and rationalize it. Okay, so that still should not have that radical left over. You would then have to rationalize using the steps. And then our next one is going to be no denominator is going to contain a radical. So kind of like what we just talked about in the bullet point above. Then we have our exponents in the radicand, and the index of the radical have a greatest common factor of 1. And then we have all indicated operations, so adding, subtracting, multiply, have been performed if possible. Okay, I think I also forgot division, but that does count too. And so to clarify, that's going to be the fact that, you can't add or subtract radicals that don't have the same radicand. And so that's kind of where that if possible will apply. All right, so we are done. Hopefully this video was helpful with going over the steps of how you perform multiplying by the conjugate, as well as why everything is going to cancel out.